Hello everyone, in this video we are going to see about the introduction to data structure. We all know that data structure is the collection of data where we can organize the data in a specific manner. So now let us see first of all what is the definition of data structures, and then we will see the operations that can be performed in any data structure, and then types of data structure. There we have linear data structure and non-linear data structure. Okay, so now the definition of data structure is it is a logical way of storing data, and it also defines the mechanism of retrieve the data. Actually, the definition says that there exists a logical way, that means a meaningful way of how to store the data in an organized way so that the data can be accessed in an efficient manner. So this mechanism may be of efficient access in the sense it may be time efficient as well as the work efficient. So how to access the data in a better way and also how to store the data in an efficient way. So that is the definition of data structure. It is a logical way of storing and retrieving the data. Now let us see the data structure types. There are in major we have two different data structures, linear data structure and non-linear data structure. So as the name implies, linear data structure consists of same type of data arranged in a consecutive memory location. Example are array, stack, queue and linked list. Everyone is very much well versed with the concept of queues. So what is a queue? Queue is a linear data structure where the elements are placed one after the other. It is similar to the queue where we form the queues in a ticket counter or in the mall for billing. So whatever there, we are forming a queue in order to get the process done. We always say first in, first out. Whoever comes first will be served first. That is the concept of queues. Okay, that is the common scenario where we are in a ticket counter so that our tickets can be processed, or as a billing counter where our bills are processed. So it's a linear data structure. Same way in computers we have many linear data structures. They are array, stack, queue and linked list. Let us see one by one in detail in later classes. And non-linear data structures, we are having two major types, graphs and trees. So these structures are non-linear, that means they have hierarchical data. One data may be dependent on the other data, one may be the subdata of the parent data, so that way the data are dependent on one another in some logical sense. So that is the non-linear data structure. We know that graph is a collection of vertices and edges, and every vertex points to the next vertex depending upon the hierarchy of which data is referred by other consecutive data. In the trees, again we have the tree branches and the leaves, where the trees have branches and branches. That means the way in which the data can be arranged in a sub level. So that is done by both the graphs and the tree structures. Now let us see the definition for a linear data structure. The data structure where data items are organized sequentially or linearly, where data elements attached one after another, is called linear data structure. That is here in the memory. We all know that every data we store in a memory of the system or the secondary memory. So whatever the memory may be, the data are stored one after the other. Here in linear data structure, the memory locations are one after the other. That is called as an organized sequentially or linearly. Okay, so now next one, the data elements in a linear data structure are traversed one after the other, and only one element can be directly reached while traversing. What is traversing is visiting, or we just meeting, that is we are just coming across, or that is the visiting that particular element. So in linear data structure, the data are traversed one after the other. That means one by one only it can be done. Okay, so that is the concept in linear data structure. Traversal is linear. We can traverse, that means we can visit the data one after the other. And all the data items in linear data structure can be traversed in a single run. So what is single run is starting from one direction to the end direction. So that is the single run. That means once you start, it will just keep on traversing or visiting the consecutive data. So that is the single run. And non-linear data structure, the data structures where data elements are not arranged sequentially or linearly are called non-linear data structures. Let us see with an example in the later classes. In a non-linear data structure, single level is not involved. Therefore, we cannot traverse all the elements in a single run only. So here, if at all, if we want to visit the data at a single pass or a single run, all data cannot be traversed. Only one branch or one section of data can be traversed in the non-linear data structure. That means this non-linear data structure has need multiple runs or multiple pass or multiple times so that the data can be visited, all data can be visited. Non-linear data structures are not easy to implement in comparison to the linear data structure. What is implementation is how to implement, that means how to make the process, how to get the data, how to put the data, and how to read the data, or how to update the data. So all those things that are called the implementation, the process. So these processes are not much easier in the case of the non-linear data structure. It utilizes computer memory efficiently in comparison to a linear data structure. Its examples are trees and graphs. So, trees and graphs are the examples of non-linear data structure. These type of data structures utilizes the computer memory efficiently. Why? Because the one data has some subdata. So, we organize or we allot one particular memory area for a data, and the subdata, which are all the components of the previous data, will be stored as a node or a collection in a particular part of the memory. So here no wastage of memory will be there in the non-linear data structure. But in the case of linear structure, we cannot utilize the memory efficiently. Now let us see the difference between the linear and the non-linear data structure. This is just we have seen earlier in the previous slides. A type of data structure that arranges the data in an orderly manner where the elements are attached adjacently. Adjacently means one after the other in the memory area. That is the concept of linear data structure. In non-linear data structure, the data are arranged in an sorted order, creating an relationship among the data elements. So the elements are arranged in such a way that the order in which the data is stored will have some meaning in the arrangement. In case of linear, it is just like chronological order. As it comes, it will be stored. That is the linear data structure. And then memory utilization is inefficient in linear data structure. In case of non-linear data structure, the memory utilization is efficient. And here in linear data structure, we have single level of storage. Here we have multiple level of storage. And it is easy to implement this linear data structure, but it is a little bit difficult than the linear data structure. And then example of linear data structures are arrays, linked list, queues, and stacks. And the example for non-linear are trees and the graphs. So that's all the basic concepts of data structure. Hope it is easy to follow, and thanks for watching.